video is to allow us to correct our homework for section 3.1.1. I first want to point out to you in the methods and meanings section that they discuss the idea of the multiplicative identity. So it says if any number or expression is multiplied by the number 1, the result is equal to the original number or expression. The number 1 is called the multiplicative identity. So again, in math, we tend to name things very logically. When you multiply by 1, you maintain the number's identity. It stays the same. So we call that multiplicative identity. So we use that in various ways in math, but one way at our grade level that we use it is to show that if you multiply any number by a giant 1, which is a number as a numerator and that same number as a denominator, which is equivalent to 1, you're going to get an equivalent fraction or an equivalent number. So this fraction of 2/3 multiplied by a giant 1 of 2 over 2 is going to give us 4/6, which means 4/6 looks different than 2/3, but it is equal in value. In other words, it is equivalent. So it is an equivalent fraction, and we can create that equivalent fraction by using our multiplicative identity. So for our homework, the first one they want us to do is to look at the original fraction and determine what was used as the giant 1 and what is the missing value. So for the first one here, we would say 3 times what equals 18? Well, that would be 6. So the denominator of the giant 1 is 6. If the denominator of the giant 1 is 6, the numerator has to be 6 because that's what has it creating a 1 for a value. And then 5 times 6 would be 30. Now, normally we don't want to leave our answers as improper fractions, but in this case, the original fraction was improper or greater than 1, so our answer will be 2. Here, we're saying to ourselves, what times 4 is going to give us 28? Because notice this is where the multiplication dot is. So even though it's on the right side, it's still, is equivalent. So 4 times what equals 28? Well, that would be 7. Again, if the numerator is 7, the denominator has to be 7. So what number multiplied by 7 would give us 63? That would be 9. So 4/9 is equivalent to 28/63. Here, what are we multiplying 20 by to give us 100? That would be 5. The denominator is 5. The numerator has to be 5. Again, that's what creates the giant 1. 9 times 5 gives us a missing value of 45. For 313, Rachel says that when she ran 115 yards, she went farther than Beth, who only ran 327 feet. Is Rachel correct? So make sure that you do the explanation for how you know. So what you should show is either taking 115 yards, multiplying by the fact that there's 3 feet in a yard, which would equal 345 feet. So yes, Rachel's running further than 327 feet. Or you should take 327 feet and divide by the fact that there's 3 feet in a yard, and you would get 109 yards, which again proves that Rachel did run farther. She ran 109 yards. Beth ran only 109 yards. Rachel ran 115. So again, Rachel ran further. Or you could say Rachel ran 345 feet compared to 327 feet. Again, in each case, Rachel is correct. She ran further. But again, make sure you're showing how you got that. Here you have to look at the histograms and then you have to answer the questions. So, which team has taller players? Which has shorter players? So what you're looking for is, which team has more players that are taller? Which one has more players that are shorter? The Tigers seem to have more taller players. So if you look at the histogram, they've got 5 players between 72 and 75 inches in height, 3 players between 75 and 78 inches in height, and a player that's between 78 and 81 inches in height, where the Panthers have less. Only 2 players between 72 and 75 inches in height, 3 players again between 75 and 78 inches in height, and 2 players between 78 and 81 inches in height. So the Tigers overall have more tall players. The Panthers has more short players. And again, for your explanation, make sure you're explaining how many players would you consider to be tall on the Tigers, How many players would you consider to be tall on the Panthers? And then which team has heights that vary more? Well, that's going to be the Panthers. We can see that they have more data that's spread out and in different bins. Remember, we call these categories on the bottom bins. So they have a player from 63 to 66 inches in height, three that are between 66 and 69 inches in height, and so on, where more of the players on the Tigers are 69 inches in height and above. And then which team has more players at about the same height? Again, the Tigers, because it has the bin that has, the highest, and so they are all the same height approximately as each other in that bin right there. Again, make sure you explain that. For 315, you need to find the perimeter of the triangle. And again, even though I just have the answer, I need to see how you got that answer. That you took 7 and 25 hundredths plus 7 and 2 tenths plus 8 and got a total of 22 and 45 hundredths centimeters. Area of the rectangle, I should either see that you counted up how many squares there were, and there were 28 square units, or that you took 4 times 7 or 7 times 4 to get 28 square units. And for this one, again, I should see how did you find the area and how did you find the perimeter. So just having the answer like I have is not going to be adequate. For the area, I want to see that you multiplied 2 times 8 or 8 times 2 and got 16 square inches. And for perimeter, that you added 8 plus 2 plus 8 plus 2 to give us 20 inches. For 316, there's a lot of different pairs of numbers that'll add together to give us 1. They said to write down at least 3. I went with a decimal, 5 tenths plus 5 tenths equals 1. Fractions, 1/4 plus 3/4 equals 1. Another decimal, 2 tenths plus 8 tenths equals 1. And of course, there's many, many, many more. Here you have to use the distributive property to rewrite them and then simplify. So the first thing you should do is rewrite this to be 12 times 300 plus 9. In other words, let me make this print a little bit bigger. We're breaking the 309 to be 300 plus 9. Now you might say to yourself, well, I would normally just take 309 and multiply by 12, but in this case, you want to write it this way because they're telling you need to do the distributive property. So you take that 12 times the 300, and then you put your plus sign down, and then you take your 12 times your 9. And then 12 times 300 will give you 3,600. 12 times 9 would give you 108. Adding those together gives you 3,708. So again, you should show more steps than I'm showing. You should show what this equals, and then the total. Now for B, they already have it broken apart. So we're going to say 8 times 100 plus 8 times 10. There's my 10 arrow, not great arrow, but there's the idea. And then plus 8 times 8. Okay. And then again, I should see this would be 800, this would be 80, this would be 64, giving you this total. So show a little more work than what I have here. For 318, I should see that you took $5.25 and divided by 5 notebooks. So I should see that you showed your long division, that you brought your decimal point straight up into your quotient, and then went through the process of 5 goes into 5 one time. 1 times 5 is 5. Subtract, we get nothing. Bring down the 2. 5 does not go into 2, so we put up a 0. Then bring down the 5, and 5 goes into 25 5 times, giving us 25 remainder of 0. So $1.05 would be our answer, but again, show that long division. For 318, this person is taking the bus to school each morning, and these were the different times that it took him to get to school. So if you had to use one number to tell how long it took him to get to school, what would you say? So looking over these, what do you think would be a reasonable answer? Maybe about 11 minutes, maybe about 12 minutes, something somewhere in between. And then if he wants to or needs to actually get to school by 8 a.m. each day, what's the latest time he should get on the bus, assuming that he can get one at any time, and how did you get your answer? So if it takes him the maximum of 15 minutes, he would have to get on the bus by 7:45 a.m. to guarantee that he would get to school by 8 a.m. For the dot pattern, you have to draw the third and fifth figures. And what you should find is figure 3 is going to have 8 dots, 4 rows of 2. So basically, we're talking about is like this, except for mine's kind of messy. And then figure 5 will have 6 rows of 2. So when you are looking for the pattern, what you see is that the 50th figure would have 51 rows of 2, because figure 1 has 2 rows of 2, figure 2 has 3 rows of 2. In other words, add 1 to the figure, and that's how many rows of 2 you should have. So the 50th figure would have 51 rows of 2, which is 102 dots. Again, explain that, don't just put an answer. And then, is there a figure that would have exactly 38 dots? Yes, figure 18 would have 19 rows of 2 dots. 19 times 2 gives you 38. For 3.21, draw a diagram of the field. So make a sketch that shows this field, and then find the perimeter. So again, I've got the answer, but you need to make sure you drew the diagram and showed how you got it. 80 plus 115 plus 80 plus 115, and then of course the right label. And then if she does that 4 times each time she exercises, how far does she walk? So again, I would want to see that you took 4 times, you know, 4 times the 390, which is how far she walks each day, and she does that 3 times in a week. So again, 4 times the 390, and then 3 times a week. So again, don't just give me the answer, make sure you show how you got that. And we do additional challenges. So a mile is 1,760 yards. How many miles does she walk each week? So we would take basically the amount of yards she walks in a week, divide by the amount of yards in a mile, and then get our answer. So you don't have to do long division here, but I should see the work. I should see that how you got that answer.